In this video, we will look into the vertical pressure and temperature profiles of the atmosphere. Shown here is the pressure variable. The figure on the left is the pressure and density variables of the atmosphere with altitude. The altitude is in kilometers ranging from 0 to 500 kilometers. You can see here that the air pressure exponentially decreases as it goes from 0 to 100 and 200 to 500 kilometers. This is the same for air density, where the difference between air density and air pressure is a constant factor. This makes sense because the relationship between density and pressure is proportional, as shown in this equation. The air pressure density decreases exponentially with altitude because the number of air molecules there are in the atmosphere gravitates to the bottom of the atmosphere. It spreads out to lower values going up to the 500 kilometer level. Now, on the right of the slide is a zoomed-in version of the figure on the left. The right axis of the figure ranges from 0 to 30 kilometers, while the left axis is in miles. We see here the air pressure on the surface of the Earth is 1000 millibar. The millibar is a common pressure unit used for the atmosphere, where 1000 millibar is equivalent to 1 bar, and 1 bar is the same as 1 atmosphere, or ATM. At the surface of the Earth, the pressure is at its maximum. It exponentially decreases until 5.5 kilometers, which goes to half of its original value. The distance between 0 to 5.5 kilometers makes up 50% of the mass of the atmosphere. Anything above that is the next 50%, which extends from 5.5 kilometers to 50 kilometers. This hints at the relative thinness of the atmosphere above 5.5 kilometers. For example, the peak of Mount Everest is 10 kilometers. And so, the mass of the atmosphere at the peak of Everest is roughly 70% of the atmosphere. The pressure is only 1 millibar at 50 kilometers above the surface of the Earth, which is a thousandth of its value on the surface. Now, altitude, or the height above the surface, is usually reported in the pressure unit of Pascal or hectopascal, or HPA. We calculate the pressure with height using the equation P equals to P naught times the exponent of minus Z over H. Rho naught is the density of the air at the surface of the Earth when Z is equal to 0. Rho naught is roughly 1.25 kilograms per meter cube of air. H is a constant, and it is known as the scale height, or the folding height, which ranges from 7 to 8 kilometers. This is the height where air pressure or density starts to decrease by 50%. If you want to calculate the height, you just rearrange this equation so that Z is on the left-hand side of the equation. Thus, this equation can be used to calculate the actual height in meters. That's the end of this video, and I hope to see you in the next one.